Okay, guys, I am currently trying to get this paper all situated in here. So I have scanned these in so you guys can see them if mine is too blurry. But let's go ahead and talk chi-squared test of association or independence. You can use either or. I tend to stick with the word association, but whichever one works better for you in your memory is the one you guys can use. They're interchangeable. So um, we talked about this the other day as far as we did chi-squared goodness of fit. Chi-squared goodness of fit is going to show up with a list of proportions, okay? Chi-squared test of association and of homogeneity shows up in table form. So like I can already look at this and see statistically significant and see a table and go, okay, it's got to be chi-squared, either association or homogeneity. So here we go. Example. Suppose we were interested in finding out what sports high school students play. In particular, we're interested in finding out if a student's current math class has any relationship with the sport that they play. We took a random sample of 335 high school students who play one sport. So they gave us a table. The table originally looked like this, and it didn't have any of these values in here. So you guys are probably just seeing 35, 42, and 11 on your paper, 34, 25, 21 on your paper. So what I would do specifically, as soon as I read the directions and I know I'm doing a chi-squared test, do these data show a statistically significant relationship? There's that phrase. If it says evidence, statistically significant, you guys know you're going to do a test. Relationship between current math class and sports played. I know that I'm doing a significance test. I'm going to want to know the total of totals. So I, by default, go ahead and total my rows. So 35, 34, 12, 25, 106. 42 plus 25 plus 50 plus 29 gives me 146. And then I also do my columns. So 35, 42, and 11 gives me 88. 34, 25, 21 gives me 80, and so on. And notice that I have 335, which is the number that they originally said that they had surveyed. Okay. I also go ahead and calculate my expected value, which you guys don't really have a place on these notes to talk how to calculate your expected value, but your expected value, when you guys are talking in terms of a chi-squared test of association, it was easy when we were in goodness of fit. It was just a percent of a number. But now that we have this table, unless you want to go back to when we did marginal and conditional distributions and you find those proportions, you're just going to want to remember the following um, equation. So expected value is going to be the row total times the column total divided by the grand total. Okay, so for example, if I am talking about geometry and I look at those, I'll give you a second. Go find the row total. Go find the column total. And then find the total, the grand total. Okay, so the row total. The row total for geometry is 106. The column total is, what am I using for the column total for geometry? Well, I'm going to do this multiple different times. So if I am finding this expected value right here, I'm in this column. So 88. And then the grand total was the 335. If I multiply those, I get 27.8. So that's where I got that expected value of 27.8. Okay, so then if I'm doing geometry again and I want to move over here, again, I do the row total, so I would have 106, times the column total. Now I'm here, so I'm going to use 80 this time, and then I do the grand total. And again, if I do that number and put it in my calculator, I will get that 25.3. Okay, so you need to know this. It's not on the equation sheet. It will show up in multiple choice. Um, Generally speaking, unless you're doing it on multiple choice, the FRQ, your calculator can put these in a matrix, and I'll show you how to do that, and it'll just spit them out. Okay, so you only need to know that equation really if you're doing your multiple choice question. So I know that this is a chi-squared test of association. It's chi-squared, there's multiple things happening, and it's in a table, okay? So chi-squared test of association. My hoe is what there has always been. There is no difference, right? So there is no association between math class and sports played for high school students. And my ha is that I think that there is some association, okay? And again, if you look at the stem of the question, is there a relationship between math class and sports played? So that's your ha. There is some association between math class and sports played for high school students, okay? So we are chi-squared. We're going to go check our conditions. So our conditions are hopefully random. We got that from here. They took a random sample of 335 students. Large sample size. I will show you how to get this out of your calculator. So when you're doing a test, it will be short, fast, and easy. You're just going to write them down in the same order that you had up here. So your calculator is going to kick them out in this order. So I just keep them in that matrix that your calculator will kick out. They're all greater than 5. And remember, these are your expected counts. This is how many I'm expecting to see in baseball for geometry. This is how many I'm expecting to see in volleyball for geometry. Okay? Independence is still the same thing that we have always done. It's still the 10% condition. So our sample was 335 students, and that's a tenth of, they're talking about high school students. There's millions of high school students. So that condition checks off. So let's go do our chi-squared statistic. Again, you could do this by hand. This chi-squared test of association is actually going to spit these numbers out, guys, and I will show you where to get them from your calculator. But it spits those out. There is our chi-squared statistic. So we want to know what's the probability that I take this sample of 335 and I get this chi-squared value, or extreme. So when I plug that in, I get 0.00006. Now I also need to reference degrees of freedom, guys. Notice that your degrees of freedom changes when you are talking about a chi-squared test of association. You can remember this as rho minus 1 times columns minus 1 and you get 6, or if you come up here and you just cross out a row and you cross out a column and then you count what's left, 1, 2, 3, 4, 5, 6, not doing your total, just that will be your degrees of freedom, okay? I think that's easier than the equation. Just cross out one row, cross out one column, whatever you're left with, that's your degrees of freedom, okay? So because our p-value is less than alpha of 0.05, we have a statistically significant evidence to reject the hoe, and we're going to go ahead and conclude that there is some association between math class and sports played. So let's talk about how to enter this into your calculator. So on your calculator, you guys have this button right here that says matrix. Mine's in blue, so I'm going to go second what looks like x to the negative 1, okay? It takes me to this screen. These are all matrices, okay? And this is how big they are. So I want to edit. So I'm going to arrow over to edit so it's highlighted. Number 1, okay? When I go in there, it's got whatever was in there last, okay? When I look at my table, it might be hard to determine what it is. When you create your matrix, do not, I repeat, do not put your totals in your table. You're only going to put in the data, okay? So I see 1, 2, 3, 4 columns, and I see 1, 2, 3 rows. So I come up here, and I can either do a 3 by 4 or notice if I do a 4 by 3, I couldn't get all my data in there. So I just go back and forth and try to figure out which one it is. Okay, so 3 by 4 is going to work. I'm going to enter in what I have. So I have 35, 42, and 11. Then I'm going to go up here and enter this one, 34, 25, 21. And then I have 12, 50, 30, and then the last one I have 25, 29, 21. Okay, so there's my matrix. Okay, so get out of there. So second quit. The nice thing is that B is going to populate with whatever your expected values are. So I want to do a chi-squared test. So I'm going stat. I'm going over to test. So we did this one the other day. There's your goodness of fit. The one we're doing today is the chi-squared test. Another way you can tell if you're doing the right chi-squared test, guys, is if you go to enter data and you just can't enter it in. There's no way we could have done our example from the other day in class for the GOF into a matrix. Okay, so I put my observed in matrix A, and I would like it to put my expected values in matrix B. Okay, so then I'm going to go down and I'm going to hit calculate. So a couple of things. One, when you look at your degrees of freedom, notice that you have 6. Our chi-squared value is what we had before, and our p-value is exactly what I had before. That's 6.1 times 10 to the negative 5th. So that decimal should be to the left 5 places, okay, which is what we have here. If I move it 1, 2, 3, 4, 5, there's your 6, okay. The other nice thing about this is if I go into matrix, to go back to your matrix and just go look at what's in B, so I hit B and then I hit enter, you can see all of the expected values that you should have had. So you can arrow over, just don't hit enter, you can arrow over and get all of those expected values right away. Okay, that's the nice thing. Now the weird thing is I'm not understanding why you should have, this calculator is not doing it, so I'll have to do some diagnostic on it. But when you do this, you should get all of your chi-squared values right here. It should say CNTB for contributed. Okay, so then you'll have numbers, and those will go in order. And those will be like what we talked about, which one contributed the most to the chi-squared value. So I'll have to look at this calculator. Okay. So a couple of things. If you're watching this video and it's 1718, we are skipping homogeneity. Okay, so we did the GOF test and we're doing the test of association. I also skipped this Skittles problem in lieu of time. So when we did the GOF, we had one variable, we had one population. That was the tobacco plants. Okay, the population was the tobacco plants. The variable was what it was. They had albino, green, yellow. Okay. When we look at a chi-squared test of association, there are 2 variables in one population. If you look back at this, you have the variables and you have the population was just high school students. Okay, and this is always going to show up in a two-way table. Okay, that's the other thing. So if we read this, if I give you guys this example, final example, read this quickly. Pause it because I'm going to move on. Do we have strong evidence to suggest that dogs like their owners? What type of test was this? Well, I'm seeing a table. I'm seeing that I have a population of dogs, right? And I have 2 variables. So I know that this is a chi-squared test of association, and I'm going to put this in my matrix really quick, see if I get that chi-squared value and that p-value out. Okay. My question is, could I have done a two-tailed 2-prop z test? And the answer actually is yes. If I do a two-tailed test for this, because I have 2 different samples, I would get a z of 1.933. If I square my z, I actually will get the chi-squared statistic that I got up here. Okay, so my p-values are actually exactly the same. So you can do a chi-squared test of association or a two-tailed two-prop z-test, but just caution, it only works for the two-sided. It has to be a not equal to ha for this to work. Okay, so that is it for 11.2. You guys now have your homework to start. You have 54. It's down at the bottom. Again, notice my notes. On 45, you only have to do the conclusion, but for 49, you should be doing the full template. So make sure you guys do that. Tomorrow when you guys come to class, I will have you work in groups on your Chapter 11 group test.